All right, so today we're going to look at our final form of quadratics, which is intercept form. Okay, so intercept form, it's called that because it's a form that easily gives you the intercepts. Vertex form easily gives you the vertex. Transformation form easily gives you the transformations. Intercept form easily gives you the intercepts. Okay, so let's take a look at what's going on in this equation. First off, you're going to notice this a value again. And like I mentioned before, that a value stays the same no matter what form your parabola is in. Okay, so this is still going to be your vertical shrink or stretch or flip. Pepper. Hush. Pepper's being a grump right now. Okay, so this is our vertical shrink, stretch, or flip right there. Okay, the P and the Q values are going to be your X intercepts. Okay, so P and Q represent your X intercepts. Okay, which are going to be the points P0 and Q0, right? So they're X intercepts, the Y coordinate has to be 0. Okay, notice that the minus sign is once again built in. So when you look at one of these, you're going to have to kind of think to yourself, oh yeah, self, it's backwards of what it looks like. Okay. All right, so that's the information that we can pull out right away. It's our x-intercepts, and we know our transformation, vertical shrink, stretch, or flip. So then we need to find our vertex. So let's talk about finding the vertex really quick. Okay, so what this form gives us for information is it gives us our x-intercepts. So if we think about just an example of a parabola, here's an example, right? So if we know these 2 points right here, and I want to figure out the x-coordinate of the vertex, well, let's think about what that means. We know, because we've talked about it before, the parabolas are symmetrical, right? So right through this vertex, there is that axis of symmetry where everything is the same on both sides, right? So if I know where these 2 points are, to find out where your axis of symmetry is pretty easy because you just have to find what's halfway between them. Right? So if I can find what's halfway between them, that will give me this x coordinate right here, which is also the x coordinate of my vertex. Okay, so that's what we're basically going to do is we're going to find halfway between these two. Okay, how do you find halfway between two things? You average them together, right? You add them up and divide by 2. Okay, so when we're looking to find our vertex, so for our vertex HK, to find H, you're going to add together your 2 intercepts and divide by 2. So your 2 intercepts are P and Q. Remember, opposite of what they look like, right? Because those built-in minus signs, divided by 2. Add them together, divide by 2 to find halfway between. And then, just like we did with standard form, you're going to plug that value into the equation to find K. Okay? You are going to sometimes need to be able to do this right off of an equation, pull this out. But when you're graphing, a lot of times you can even sort of skip that formula if you can find halfway between just by looking. So let's take a look at this guy. So the first thing I'm going to do is I'm going to pull out my 2 x-intercepts. So my 2 x-intercepts, remember there's a built-in minus, so it's backwards of what it looks like, is going to be -3, 0, and then 1, 0. Okay, so I can start by plotting those 2 points. Here's -3, 0. Here's 1, 0. So when I go to graph this, I could start by just finding where my axis of symmetry is. It's halfway between, right? So here is the line that's halfway between those 2. Okay, so if you're going off of a graph, a lot of times with these ones you're going to do in class, it's just as easy to just look for halfway. If you're going off of the equation and you have to actually calculate it though, how would we calculate this? Well, I would say, okay, I need to find halfway in between. So I would do h equals -3 plus 1 divided by 2. Again, notice that the signs are backwards of what they look like. So -3 plus 1 is -2, divided by 2 is -1. That's where we drew our axis of symmetry. Okay, and then to figure out where's my vertex going to go on the y part, I'm going to plug -1 into this equation. So it's going to be -2 times -1 plus 3 times -1 minus 1. Plugging this guy in there for x. Okay, order of operations, parentheses first, so that's going to add to 2. This guy's going to subtract to -2. When I multiply all that together, that's going to be positive 8. Okay, so that tells me that my vertex is over at -1, 8. So here's -1, +8. There we go. Okay, and then the last thing that we're going to do is we're going to use our transformation, right? This tells me that I have a vertical flip and a vertical stretch by a factor of 2. So from this point, normally I'd go over 1 and up 1. I'm going to go over 1 and down 2 in this case. Normally I'd go over 2 and up 2. Well, I'm going to go over 2 and down 4 in this case. Over 2, down 4. Oh, duh. I'm sorry. 2 squared is not 2. I'm doing this wrong in my head. 2 squared is 4. So normally we go over 2 and down, over 2 and up 4. Excuse me. Now we're going to go over 2 and down 8. Okay, and if you notice, I just troubleshooted myself because I was looking at this and I was like, oh, okay, well, my brain was wrong, right? And I was thinking that I should go over 2 and down 4, but I was looking at it and I was like, oh, look, I can't have a point there. That doesn't make any sense. There's already a point on that line, right? That breaks my function rule. So something must be wrong. And that's what made me go back and double check myself. Okay, so that is a really common or really important thing for you to be able to do when you're working on these problems is check yourself and make sure that you're doing it right. Okay, I can reflect this point over here. And I don't think I'm going to be able to fit anything else, right? The next one would be 3, 9, and 9 times -2 is going to be -18. That won't fit. So there's my parabola. Not sure if you can hear it, but my neighbor just started mowing their lawn. Great. All right, cool. So then down here, the last thing that we're going to do is we are going to rewrite going from intercept form into vertex form and into standard form. Okay, so what we're going to do, notice that this is the same equation from here. So I've already done some work. So for vertex form, we've already figured out that the vertex is -1, 8. -1, 8, right? So once I have my vertex and I know my a value from here, this is really easy. Vertex form is pretty friendly, right? So it's going to be y equals the same a value of -2, and then it's x minus the x coordinate, so minus -1 is +1 squared, and then plus your y coordinate of your vertex. There we go. All right, so that was nice and easy. And again, that is the same a value as before. All right, now to do standard form you're going to have to do a little bit more work for. In order to do standard form, you're just going to simplify this, right? We're just going to follow order of operations and multiply this stuff out. So you could multiply in any order you'd like. You could distribute the -2 first to this set of parentheses. Don't distribute that -2 to both sets of parentheses. We're just multiplying 3 things together here, right? So you could distribute it here and then multiply that with that. Personally, I prefer to multiply these guys first. So I'm going to do that and I'll do the -2 after. It doesn't matter. You're allowed to multiply in any order that you'd like, right? So when I multiply these 2 binomials together, x times x is x squared. X times -1 is -1x. 3 times x is 3x. 3 times -1 is -3. Okay, I can combine these 2 middle terms together. So then that would be -2 times x squared plus 2x minus 3. And now I can distribute this. So it'll be -2x squared minus 4x plus 6. There's my equation in standard form. Okay, so all standard form is it's just totally simplified. That is the other dog. That's Watson. He's barking, probably because the mailman's coming down the street. All right, so that is it for intercept form. Intercept form, not too bad.